So there are a few different things that we can use differentials for. I've listed a few of them here. These are the ones that seem to come up the most in the assigned problems. One is estimating values. The other is estimating change, and the third is estimating error. I should point out that estimating values is really just a different way of using the linearization as we did in the earlier examples, and I'll show you why. So first, let's consider this question. Let's use a differential to find the approximate value of sine of pi over 6 plus 0.01. So we can see here is that we have, we're trying to estimate the value of the sine function at kind of an unusual value. So let's say that let's define it this way. Let's suppose that y is equal to the sine of x. If that's the case, then dy is equal to cosine x dx. In other words, if you prefer, we could have just written dy over dx equals cosine of x and then just multiplied both sides by dx. So that's how we got to that point. Now, what you can see here is that we have, in the original problem, we have a number pi over 6 where it's very easy to calculate the value of sine. We should all know by now that the sine of pi over 6 is 1/2. And then we have this kind of increased amount that of point, 0.01 that we're looking for the value that's 0.01 more than that very easy value. So we could do is simply say that this is dx. I'll show you why in a minute, why that makes sense, but for now just bear with me and let's just say that that's dx. If so, oh, and also let's call this x itself. So if this is the case, then we can say that dy is equal to the cosine of pi over 6 times 0.01. Now the cosine of pi over 6 is root 3 over 2, and multiply that by 0.01. Root 3 over 2 is approximately 0.87, so we'll multiply that by 0.01, and then finally that comes out to 0.0087. And by the way, don't look at this and say, wait a minute, why did you stop at 2 decimal places when you were estimating root 3 over 2? I need to know exactly how many decimal places to use on some future quiz. If you're asking that, you're not seeing the forest for the trees. On a quiz, you would be told either to use an exact value, which is usually the case, or you would be told what precision to estimate a decimal with. So don't worry about that. Anyway, the so anyway, let's see what this means. What the interpretation of this is that if I increase if I increase the x value, if I increase the argument to sine by 0.01 from the sort of easy position of pi over 6, then I'm going to increase the y value by 0.87 from what the sine over pi over 6 was. Before we interpret this, let's draw what this looks like. What we're saying here is that if this is the sine function, which it is, looks like that, and here's pi over 6, and that's 1/2. So this is a picture of what it means to say that the sine of pi over 6 is 1/2. So now I'm just going to draw, I know this is kind of exaggerated, but let's say that that's pi over 6 plus 0.01. So what we're saying is that I started at 1/2, and instead of following the actual function, I followed the tangent line up to here. So I moved 0.01 into the right, and because even though I know this tangent line looks very steep, it's not really. Because we know the derivative of sine is cosine, we know that the slope of this tangent line is the cosine of pi over 6, or root 3 over 2. So when I moved 0.01 to the right, that means that in other words, if the run was 0.01, in the horizontal direction, I must have risen or moved in the vertical direction by the slope, root 3 over 2 times 0.01. So what that means is that this point here must equal 1/2 plus this rise along the tangent line, which is what we call dy. So it's 1/2 plus dy, which we just calculated. So if that's 1/2, then this is going to be 1/2 plus dy. So, and of course we would have gotten a different value for dy if I had chosen a different value for dx, but this is the one we chose. So that means that it's correct to say that sine of pi over 6 plus 0.01 is approximately equal to 1/2, which is 0.5, plus 0.0087, so that comes out to 0.5087. That's the That's the approximate value. And yes, I am using the equal signs right. I'm saying that sine of this number is approximately equal to zero point 0.5 plus 0.0087. And of course, once I add them together, that is exactly equal to 0.5087. So I am using the equal signs correctly, if you're wondering. Um, by the way, you can see this example. This is still in section 3.11 of the textbook. It's done exactly like this. And just note that what we could have done is equivalently to this, we could have simply said that L of x at the point x equals pi over 6 is equal to is equal to f of pi over 6 plus f prime of pi over 6 times x minus pi over 6, which in this case would be 1 half plus root 3 over 2 x minus pi over 6. And you'll see that if I simply plugged in pi over 6 plus 0.01 in place of x and then performed this calculation, I would have gotten to exactly the same place. That's because this itself is just the differential dy.